Over the years at Hornady, we pride ourselves on quality, and it begins right from the design phase. You know, in our 2 and 3D, CAD models, we'll design our tooling and dies and punches, which machine we're going to run a certain product on, to try to tailor the whole design manufacturing process and gear it towards quality, with quality in mind. The majority of us here at Hornady are, we're hunters, we're competitive shooters. We take our self-protection very seriously, and we really want to make the best products out there.
Sometimes we'll simply see a void somewhere. There's a product that could work better in this environment. But sometimes it's through use. I'm out shooting a match, or I'm out hunting or something, and an idea will come up that says, hey, we could make this better, or we could do this that would be better.
We started back in 2012 with a goal that wound up turning into what's the ELD-X bullet, extremely low drag expanding. It's one thing to take one segment of, say, a velocity regime that goes from 3,000 down to maybe 1,600 foot per second. That's a really wide range, and you can kind of hit one half or the other of that pretty easily. But to get something that performs over that entire extreme is a really tall order.
This week we're in Grand Island, Nebraska, getting our hands on Hornady's new ELD-X, Extreme Low Drag Expanding Bullet. Now this is a bullet designed specifically to be a good hunting bullet at close ranges, at high velocities, but also to have great terminal effects further down range when the bullet started to slow down. It's really an impressive design, but maybe more impressive is the fact that it's also match accurate, even beyond 1,000 yards.
In working on this project, we thought we had it. Our terminal performance was great. We had a very good design from an aerodynamic standpoint for your BCs and stuff, and we were ready to go. We were ready to launch this thing, and we went out to do some final testing with it to get the actual ballistic coefficient numbers and stuff like that. And that's when we discovered the problem of the aerodynamic heating.
What we were able to determine was, with these heavy, very high BC low drag projectiles, from about 200 to 600 yards, the drag was dramatically increasing on these projectiles because the tip was getting bigger because of aerodynamic heating.
We were testing on Doppler radar, and you can't lie with Doppler. I mean, it's pure numbers. And what we saw there showed that the BC was degrading, and so we had to stop. We said, hey guys, we can't release this. There's something going on here.
It wasn't just us. We tested everybody's polymer tip bullets out there, and they all do it. It's just none of us ever knew because we didn't have the instrumentation capability to figure that out.
So what we had to do was find a material that could stand up to that heat and hold its shape and not deform. We tested composite materials with metals injected into plastics. We tried many different plastics, and what we come up with the heat shield tip is basically twice the heat capacity as what we had before, and it can hold up to the heat and not deform. That's why it has consistent BCs.
This bullet is a little bit unconventional. It's designed to what we call continuously expand. Because of the tip design and the jacket tapered design, it is meant to continuously mushroom, shed a little bit of material, mushroom again, shed a little bit more material. So even at very high impact velocities at short ranges, you wind up with 50 to 60% retained weight and a very large wound cavity that goes very deep in the animal. It's very, very effective. At long range, we discovered a lot of things along with the heat shield tip in terms of very, very tight tolerances that have to be held in terms of the tip cavity design in the lead, the design and the shape and the finish of the mouth of the jacket, and a number of things that go into ensuring that that tip at low velocity will actually set back into the bullet and initiate that expansion even down to a velocity of about 1,600 foot per second.
Want to know what's happening at American Rifleman? Follow us on Twitter and like us on Facebook. We'll be right back.
Most of the bullets that we had up to this point in time were for traditional use type stuff, the traditional hunting ranges of say out to 300-400 yards. That's where our bullets were designed to perform. And in the last 5 years or so, it seems like the skill of shooters and the equipment they use has allowed them to extend that out a bit. And we didn't really have a product that was designed to meet their needs past those conventional ranges. And there was product out there already within the industry that we didn't feel met the bill that was needed for those guys. And so we set out to design something that would fulfill their requirements for any range they might encounter within their skill level.
Not only do we take the bullets after they're designed and test them for accuracy and precision and all those things, on the hunting side, we're known for accurate, deadly, and dependable. And the dependable part of that is those bullets have to perform terminally the same every single time through a broad range of requirements, whether it be different velocity levels, i.e. ranges, media that the projectile may encounter. So rest assured that we are doing all of that testing up front and subsequent testing during manufacturing process to make darn sure that those bullets meet the expectations of our customers all over the world.
It's easy to build a bullet that'll work close up or a bullet that'll work downrange, but it's hard to do both. So that was criteria number one. This thing had to perform terminally. Criteria number two would be accuracy. This thing has to be match accurate, because as you start extending that range farther and farther, it becomes more difficult to put that bullet in the exact place it needs to go. So if you have a match accurate bullet, that's what's critical to make that shot happen. And then the third was the aerodynamics of it. The ballistic coefficient needs to be high to be able to have a flatter trajectory, to be able to resist the wind deflection. Stuff like that is all going to contribute into being able to make that shot past conventional ranges.
What the consumer needs to know is that ballistic coefficients can definitely be misused as a marketing tool for a company. And there are ways that they can manipulate this number to come up with very artificial looking numbers. And it really is a disservice to the industry and especially to their customers, because when they go to use these numbers, if they haven't been corrected back to a standard or shot in a standard way, they're going to get completely erroneous results for their trajectories. They're not going to impact where they think they're going to impact, particularly at longer ranges. And I think in the future, people are going to start looking for, how has your ballistic coefficient been determined? How was it calculated? Is it corrected back to a standard? How many points over what distances did you measure your ballistic coefficient? And I think that the trend that's going on right now with more and more sophisticated measurement techniques for the aerodynamic performance of a projectile are going to reinvent how this is done in this industry, and it's going to give the consumer, the end user, much more accurate information that they can then use to get much better results when they go out and shoot.
Developing an all-range hunting bullet, one that will expand in virtually any condition, that's a tough nut to crack. Jaden, what all is going on in this bullet that allows it to perform so well in those conditions?
A lot. We asked a lot of this bullet to be able to work at close range and equally as well at farther distances. The heat shield tip is the first part of it. That helps us not only aerodynamically on having high ballistic coefficients and good accuracy to get the bullet on target, right, but it also initiates expansion. It's a mechanism to initiate the expansion. And on a hunting bullet, you really want that. You don't want the target to control what your bullet will do. You want your bullet to control what the bullet will do.
Right.
And so the tip initiates the expansion. It starts it. Once the expansion has started, we have a very critical specification on how this jacket is designed and how the tip interacts with the internals of the bullet, and the jacket helps to control how that bullet opens, which we're asking it to do a lot. At a closer range shot, you have a lot of velocity, a lot of energy. It's pretty easy to get a bullet to open. But at the same time, at farther ranges, you've lost a lot of that velocity, and it's harder to get the bullet to open. So it was really critical on kind of blending all those, the heat shield tip, the jacket, the core, and the relationship all those play in getting the bullet to work at both close and
right.
farther range.
And I can speak from experience that this bullet, I've seen it take game at different ranges in different conditions. The terminal performance was excellent, and now out here we got a really good chance to demonstrate it's also match accurate.
It is. It is. You shoot this for a little while and you start to forget that you're shooting a hunting bullet. You start thinking, man, I'm shooting a match bullet, and you're not. This is a hunting bullet that is match accurate.